Hello there, I am Dr. C.N. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Welcome once again to my YouTube channel. Thank you for joining me in this session of looking at very important topic in statistics, and that is probability distribution, normal or probability distribution. We're still going to look at yet another example so that we can establish our understanding of how we can solve problems in normal distribution. I will encourage you to look at the previous videos, and as you get along with me, please ensure you have a normal distribution table with you. Have your calculator so that you can follow me as we look at this solution together. Let's look at what we have for now in this example. As you can see up there, we have example 3. And in example 3, the question is, the lifetime of 20,000 touchlight batteries produced is normally distributed with a mean of 340 days and standard deviation of 30 days. The question is, what percentage of the batteries is expected to last more than 350 days? Number 2, how many batteries are expected to last less than 325 days? And number 3, what is the probability that a battery selected will last more than 360 days, and then between 340 and 360 days? So let's solve this problem together with me very quickly, as fast as we can. We'll pick the first one. Let's say A here. The question is, what percentage of batteries is expected to last more than 350 days? So how do we represent that in statistics? We'll say probability is X greater than 350 days. That's what we have as the first probability. What do we do next? We now standardize this value with our Z-score formula. So Z-score is equal to X minus the mean all over standard deviation. So, and that will give us 350, which is our mean, which is our X value, minus 370. 370 is the mean, divided by standard deviation of 30. Standard deviation of 30. So this gives us what? This is 20. 20 divided by 30. And our Z-score for this value will be what? Can you do that with me? It's minus 20, so minus 0.67. So that's what we have. Now let's represent these values in our normal curve. So let's draw the normal curve like this, and then we have a normal curve. This is our mean. Mean is 370, and we're looking for values more than 350. Where should 350 be? 350, this is our mean at the center. 350 will it be on this side or on this side? Of course, it will be on this side. So let's draw another line to show the X value of 350. Now, at the center, Z-score is 0. But Z-score here is now minus 0.67. So our task now is to find what the value of 0.67 is on the normal distribution table. But before then, we're looking for batteries that will last more than 350. So more than 350 will be all of this. Will be all of this. This will be all of this. More than 350. So everything here. And mind you, this side of the curve is already 50%. Remember, it is symmetrical, so this side is already 50%. So we're looking for probability of this mean value to this data point x value. So whatever we get here, we'll now add 50% to it. So let's go to our table and look for 0.6 under 0.07. This is 0.6 plus 0.07. That will give us 0.67. That's why we're looking for 0.6 under 0.07. Follow me here on our... Let's look for 0.6. Are you with me? Yes, this is 0.6. And then under 0.07. Follow me. Follow me, follow me, follow me, follow me, follow me. This is where we are. So look at 0.6 again. And you follow me on and on and on until we get to, this is 0.2486. 0.2486. Let's see a similar value in our total distribution table. I'm going to use this one again, 0.6. This is 0.6. And then let's look for 0.07. And this is where we are. Okay, so this is what 0.6. And then we come to this point. Mind you, what we had there was 0.2486. If we add 50%, 0.5, we are going to have 0.7486. This is 86, approximately 86. So we're correct with that. So we'll now put our normal value. So Z score of 0.67, the normal value will be 0.2828 what? 2486. I think so. That is 2486. Okay, 2486. But because we're looking for everybody that is above all the batteries that will last more than 350, everything here, we are going to have add 0.5 to 0.2486. So the answer will be 0.7486. The question is, what percentage? So we are going to multiply this by 100. This will give us 74.86%. This is the answer for number one. That's the first one. Let's look at the second one, B. B is how many batteries are expected to last less than 325 days. So that will be P into X less than 325 days. Let's now do our X, our Z score. X minus mean all over standard deviation. This will give us 325 minus 370. The mean is 370 divided by standard deviation of 30. So what would that give us? This will give us 325 minus 370. That will give us minus 45 divided by 30. This will give us what? Minus 1.5. Minus 1.5. So we will now draw. The next thing is to draw our normal table. The normal curve, so that we can represent the values we are looking for. So let me draw this like this. Let me pull this like this and then go like this. So here we know that this is 370. That is the mean value. The mean value is 370. and we're looking for 325. 325, is it going to be on this side or on this side? It's going to be on this side because these are the center. So we're going to put 325 here. So x is 325. Now z-score at mean is 0. Now z-score here is minus 1.5. Now we are looking for batteries that will last less than 325. Less than 325. Less than 325. This is less than. Take note of this. Less than. It's not more than. So we are going less than. So we're going to shade off this. This is less than 325. We're going to shade this. What we're doing now is that we're looking for values from here to here. The probability from here to this data point. So whatever we get as probability from here to here, we are going to deduct from 50% because this portion of the curve is 50%. But we have only gotten from this to this. To get the balance will be to deduct from 50%. I trust you remember, you got that? Let me repeat it again. What we want to find, the probability we're looking for is from this value, from the mean to the data point. And that's what we're going to find in our normal distribution table. But the end of the story will actually be that we deduct the value we're going to get from our probability distribution table from 50%. This part of our distribution table, from our normal curve, is 50%. But we want only this area, this part of it. So, and this part of it is, we're going to deduct from 50%. So let's go to our normal distribution table. We are going to write z-score is equal to minus 1.5, and then our normal table, normal value is what? Let's go to our normal table. Let's go to our normal table. Our normal table, we're looking for 1.5. We're looking for 1.5. So this is 1.5. Yeah. Can you see that? This is z-score. We're looking for 1.5. This is 1.5. 1.5 under 0.00. That's 0.4332. 4332. Okay, let's continue. So this will be 0.4332. But because we're looking for values that are less than 0.5, this value, we're going to deduct this value from 0.5. So we're going to say 0.5 minus 0.4332. And that will give us what? What would that give us? That will give us 0.0618. So that will give us 0.0618. That's about 6% of the value. But the question now is, how many batteries are expected to last less than 325? How many batteries? That means we are going to multiply this value that we have by 20,000. How many batteries? That will be times 20,000. So this will give us what? 1,236 batteries. So this is what it will give us. I trust you're following. Let's quickly go to the third one. So number C, I'm going to move to this side of the board. What is the probability that the battery selected will last more than 360 days? More than 360 days. How do we write that? Alright, so we'll now move to the third part of our question, and that is C. Let's move to this side. The question is, what is the probability that a battery selected will last more than 360 days? I think it should be 380 days here. It should be 380 days. Okay. All right, so let's now, how do we write that in statistics? We'll say probability is x more than 380 days. So we'll now solve for our z value, so our z score. Z score will be 380 minus 370 divided by 30. So this will give us 10 divided by 30, so that what we have is 0.33. This is our z score representing this value. We will now draw our normal curve like this, and then in our normal curve we know that the mean is 370. Now where will 380 be? Will it be on this side or on this side? Obviously it will be on this side, so we have 380 here, and then the question is more than 380. More than 3. Where are we going to shade? We're going to show more than 380. So we're going to shade of this part. We're going to shade this. So as z score at mean is this. Z score here is 0.33. So whatever we're going to get, we're going to look for the normal or probability value for between here and here, between the mean and this data point. Whatever we get, we'll deduct from 0.5, because this part of the distribution curve, this normal curve is 50%. So we're going to deduct whatever we get from 50%. If it were the total curve, is the total normal distribution table, we will deduct from 1, because we're looking at the whole thing. So let's write here first of all. We have z score, z of 0.33, and then the normal value. We'll go to our table to find this. So what are we looking for? We're looking for 0.3. This is what we have. This is 0.3 under 0.03. So this is what we have, 0.03. So this will give us 0.1293. Let's go to our workstation. So we have 0.1293. I told you whatever value we get here, we will deduct from 0.5, because that is the remaining part of the portion on the curve. So this will be 0.5 minus 0.1293, and that will give us 0.3707. So 0.30 tells us 0.37. Now you will realize that the solution we gave to this question is a mirror of what we gave to this question. You see that when we got to this point at the extreme, we deducted from 0.5. Also, when we got to this question and we saw the extreme on the right, we deducted from 0.5. Now let's deal with the last question. The last question, that is D. Now come to this side. We're looking at two values here. The question is, what is the probability that a battery selected will last between 340 and 360 days? So how do we write that? P is 340 less than X less than 360 days. That's what we have. Now we're going to deal with two Z values now, Z scores. So we have the first one is 340 minus 370 divided by 30 equals to 340 minus 370. What would that give us? That will give us minus 30 over 30, and that will give us minus 1.0. The second one is 360 minus 370 divided by 30. This will give us, what would that give us? That will give us minus 10 divided by 30, and that's similar to what we had earlier. No, yeah, this will be minus 0.33. Minus 0.33. Now, we will now draw our normal curve as the next thing we do to know what we're looking for. Here, our mean is 370 at the center. And 340 will be on this side. First of all, 360 will be closer to 370. So here is 360. And 340 is also on this side. We also have 340. So we have 340. Now, where are we going to shade now? Well, we're going to be between 340 and 360. So this is where we're going to shade. This is where we'll shade. We'll shade this portion. So when we go to our normal distribution table, we'll look for the normal value for 340. For minus 1.0, and then we'll look for 0.3. And what do we do with these values? We will deduct the bigger one from the smaller one. Deduct the smaller one from the bigger value, because both of them are on one side of the distribution curve. They are on one side. So you deduct the bigger one you deduct the smaller value from the bigger value when both data points are on the same side of the normal distribution. So let's write here z-score of minus 1.0 equals to then another z-score of minus 0.33 equals to. Let's now go to our normal table and find out what these values will be. We're looking for minus 0.1 minus 1.0, I beg your pardon. That's 1.0. This 1.0. That will give us 0.3413. And the second one is 0.3 under 3. That's 0.1293. Let's now write these values here. So this is 0.3413, and the other one is 0.1293. As I told you, since both of them are on this side of the distribution curve, you will deduct the smaller from the bigger one. We are trying to find, so what we have done that we found the value of this from this mean to this point, and from this mean to this point. So to find the value of here to here, we have to deduct the smaller from the bigger one. So obviously it's already here, so I'm going to find the difference, and the difference, as you can see, is 0.212. So that's what we have as 0.212. Even if you're using when you are using the total curve, whatever values you have, you will deduct 0.5 from it, because you are dealing with 1/2 of the distribution table, and you will result in getting these values, and you will deduct 2, you will still have 0.21. So this is the answer to this question. I want to ask you to go over it again, have your calculators with you, have your normal distribution table with you, and solve these questions. Master them and prepare very well for any exams that you might be faced with. Do not forget to leave a comment in the comment section, like, share this video, and most especially subscribe so that you can get more notifications in coming days. Thank you.